figures. So application of geometric figures. Students, after this lesson, you are expected to apply the concept of congruency to solve different problems. So, we'll see the application of congruency of geometric figures through examples. Now, the first example. Example 1. Example 1. Show that the diagonal or the diagonals of a rhombus bisects angle. So, how do we show this? Here it says the diagonal of a rhombus bisects this angle. Now, let's see this problem together. Look. Here you have a rhombus. Assume this one is this. So assume this is a rhombus A, B, C, D. You know that all sides of rhombus are congruent. The question here says the diagonal, this diagonal bisects angle A. Again, this diagonal bisects angle C. So, how do we show this? Okay, now, to show this, look the triangles ABC and triangle ADC. What do you see from these two triangles? In triangle ABC, the two sides are congruent with these two sides, and side AC is common for both triangles. So, these two triangles are congruent by side angle side theorem. That means side AB is the same as side AD. Again, as you can see, side BC is equal with side CD. Side BC equal with side DC. And the third side AC is congruent to itself. It's a common side, or CA or AC. Or I can say AC is congruent to AC, or common side for both triangles. Common side. Therefore, we know three sides of this triangle with this one. The three sides of this triangle is congruent with these three sides of the other triangle. So the two triangles are congruent. In what order do these two triangles fit? Let me write the order. Triangle ABC. Triangle ABC is congruent to 1. These two are congruent. From AB fits with AD, BC fits with CD. Therefore, ABC is congruent to ADC, triangle ADC. Okay, so from this, we have to show that this angle and this angle are congruent. This diagonal bisects the two angles. We have to show this. Since we know these two triangles are congruent by side congruence test, the next step is just angle, you can see angle BAC. From this, measure of angle BAC. Angle BAC, that means, is congruent to measure of angle DAC. Measure of angle DAC. So this shows that this diagonal bisects the angle into two equal parts. So you can conclude that, therefore, here diagonal AC bisects angle BAD. This is total angle is bisected into two equal parts by this diagonal. Bisects angle BAD. Again, we can see this angle. Measure of angle BCA. Look, measure of angle BCA. Measure of angle BCA is congruent to DCA in the same order. BC, DC, and then A. Measure of angle DCA. Therefore, this means angle BCA is this one. This angle is congruent to angle DCA. Angle DCA is this angle. Therefore, this angle of rhombus is bisected. Each of these two angles are bisected by the diagonal. Therefore, again, AC bisects angle BCD. Therefore, we can conclude that the diagonal of a rhombus bisects its angle. You see it. Now, we'll proceed to the second example. Example 2. Example 2. Suppose ABCD is a rectangle. ABCD is a rectangle, and E, F, G, and H are the midpoints. The midpoints of AB, BC, CD, and AD respectively. Suppose you have rectangle A, B, C, D. A is the midpoint of AB. F is the midpoint of BC. And G is the midpoint of DC. H is the midpoint of AD. Then show that A triangle HAE is this congruent to triangle FBE. Okay, now here you have triangle on this side. So here we are asked to show that triangle HAE is congruent to triangle FBE, Now, let's see this together and I'll give you one question for you. In this triangle, this rectangle, so you know that all angles of a rectangle are right angle and opposite sides of a rectangle are also congruent. So since this is a midpoint, this side is congruent with this side. Again, this is a midpoint. The total side AD and BC are the same. They are congruent. Opposite sides of rectangle are congruent. Therefore here, half is also congruent. That means BF is the same as FC. Again, here you have side AB and side DC are also congruent, the opposite sides of a rectangle. So this is a midpoint, half of each of these also congruent. That means this side is congruent with this side. Again, this one is congruent with this. Now, here the question is, show that this smaller triangle is congruent with this one. If you cut out this triangle and put it on this, it fits. So show this. To show this, look at the triangles. You have two sides. The two sides, the corresponding sides of these triangles are congruent. AE and BE are the same. AH and BF are also congruent. In addition to that, you have the included angle. The included angle between the two sides is 90. Again, here it is 90. Therefore, these two triangles are congruent by which test? Side angle side congruency test. These two triangles are congruent. Therefore, we can write the congruency in this order. Triangle HAE. Triangle HAE is this congruent to HAE. The order, look the order. HAE from mark 1 to mark 2. You move in that order for this. 1, 2, 1, 2. So FBE. Triangle FBE. By which test? Two sides and include angle. That is side angle side congruency test. This will be the answer. Now, please students, try this. B. Show that, or here, show that triangle FCG, triangle FCG is congruent to, triangle FCG is congruent to triangle HDE. FCG is congruent to HDE. So please students, try this question I will give you 20 seconds for this. Students, have you tried the question? Very nice. Let's see the answer together. Here it says, show triangle FCG. FCG, this triangle, fits with HDE. HDE with this one. As you can see, these two triangles, the two corresponding sides of this triangle is congruent with the two corresponding sides with this one. That means side HD is the same as FC. Again, side DG is same as CG. In addition to these two sides, the included angle for both is the same. Therefore, these two triangles are congruent by side angle side congruency test. So, to write the congruency, order triangle FCG. Triangle FCG, it is congruent to, from this mark to this one, you move in the same order for this. 1, 2, from 1, 2. So HDG. So triangle HD. So by which congruency test? By side angle, side congruency test. So this is it. Now, let's continue to the next example. Example 3. Show that the altitude from vertex angle of an isosceles triangle divides the triangles into two congruent triangles. Divides the triangles into congruent triangles. Here it says you have an isosceles triangle, an isosceles triangle A, B, C. You know that in a isosceles triangle, the two sides are congruent. So these two sides are congruent, and the angle formed between the two congruent sides is called vertex angle. This one we call it is a vertex angle. Vertex angle. So the question here is an altitude from the vertex angle means it is this one's altitude. Altitude is perpendicular to the base. So this altitude divides the triangles into two congruent. Show this. This is a question. Now, how do you show this? Okay. To show this, what do you know from this and this triangle? Okay, the first one, side AB and side AC are congruent. So here, side AB is this congruent to side AC. This is given since the triangle is an isosceles triangle. Again, second, this angle. I can take this angle since it is a perpendicular, angle ADC. Measure of angle ADC. Since it's an altitude, this is 90 degree. It's the same as angle ADB. It's the same as measure of angle ADB with 90 degree because AD is altitude. So we know this angle is congruent with this one. Okay. The third one, since this triangle is an isosceles triangle, in isosceles triangle, base angles of an isosceles triangle is congruent. That means if you have isosceles triangle, if these two sides are congruent, we call this it is a vertex angle. And these two angles are base angles. These two are base angles. So, in isosceles triangle, base angles are congruent. So here, the base angle of these isosceles triangles are this angle and this angle. They are congruent. Angle B and angle C are congruent. Measure of angle ABD is this congruent to measure of angle ACD. Measure of angle ACD. Base angles, because these two are the base angles of the triangle. So here, from angle sum theorem, we know these two angles are congruent with these two. So the third angles of these two triangles also equal. Therefore, since these two angles are congruent, the third angle must be also congruent in triangle, because the sum of interior angles of a triangle it is 180. Adding these two, the remaining part, since these two are the same, these two angles are congruent. So, fourth, measure of angle BAD. Measure of angle BAD is this congruent to measure of angle CAD. Measure of angle CAD. So we know this angle is congruent with this one. So now we are ready to write the congruency. Here you have two angles and one side included side. Again here, two angles and the included sides are congruent for these two triangles. So this triangle fits on the second triangle. In what order? Triangle ABD. Triangle ABD is congruent to, you start from this angle and you move on the base angle. So start from this and move to the base angle. So ACD, triangle ACD by which theorem? By angle side angle. Two angles and the included side. Therefore, as you can see, the altitude divides the triangle into two congruent triangles. I mean, the altitude from the vertex of an isosceles triangle divides the triangle into two congruent triangles. That's it. Now, we'll proceed to the last example. Example 4. Consider the following figure. if AC is perpendicular to BD, and BC is equal to CE, which equal to 6, and AE is equals to 4, then find A, the length CD, and find the length BD. Measure of angle ABC. Angle ABC is this congruent with measure of angle DEC. Then find length CD and length BD. Find this length CD and length BC. So let's try this question together. Okay, here let's see the givens. AC is perpendicular to BD. That means AC is perpendicular to BD means this angle is 90 degree and this also it is 90, since this line is perpendicular to BD. Okay, now again was given BC and CE are equal. The length of BC is 6 and the length of CE, this length is also given to be 6. CE and BC are congruent, given. These two, 90 with 90, this angle with this one. In addition to that, side CE, the included side CE is the same as side BC, the included side BC. So these two sides are congruent. So this triangle and these triangles are, even though the triangles is not drawn in scale, but from the given, this triangle is congruent with the upper triangle. By which theorem? We have two angles in the included side. You have two angles in the included side. By angle, side, angle, angle, side, angle, these two triangles are congruent. Therefore, here I can write in this form. Triangle, let me write this, CAD. Triangle CED is this congruent to CED from 90 degree to this angle. You move in the same order for the other triangle. So from 90 degree to this one. So CBA is congruent to triangle CBA, by which congruency test by two angles in the included side, that is angle side angle congruency test. So from this we need to find the side. So if two triangles are congruent, their corresponding sides also the same. So here one from this you can see that side CE is the same as side CB. Okay, again here side ED is this congruent to side BA. Okay, again here you can see that side CD, it is congruent to side CA. Now from the given, let's see. Okay, here CE is 6. CE is 6. Therefore, CB is also it is 6. It's given. CE and CB is given. It is 6. Okay. Now here, ED. So side ED is congruent to side BA. These two sides are also congruent. Now here, side CD, this side CD is the same as CA. Where is CA? CA. CA means it is from CE is 6, from E to A is 4, length of CA is 4 plus 6. CA is 4 plus 6, it is 10. Therefore, for the first question, we are asked to find the length of CD. The length of CD is this CA, which is this 4 plus 6, it is 10. Therefore, for the first question, the length CD is this 10 units. And the second question is find the length BD. Length BD is this the sum of BC and CD. It is the sum of BC and CD. Therefore, this will be equal to BC, it is 6 units, plus CD, we have found CD, it is 10. Therefore, plus 10, it gives you the 16 units. So this all. So this all about this lesson. I will give you exercise for you to try it at home. One. Show that the diagonal of a square shows that the diagonal of a square makes 45 degrees with this side. 2. Show that the altitude of an equilateral triangle divides the triangle into two congruent triangles. So please copy the question. I'll give you 1 minute to copy the question. Okay, students, Have you copied the questions? Very nice. So this is all about today's lesson. Please try the question in home. This is all about today's lesson. Until next lesson, goodbye.
We are the ghetto kids from the Pearl of Africa, Uganda.